Last class, the very first class, some important nodes in the periodic function. If of x be a real valued function, there exists a smallest real number t such that a smallest positive number t such that f of x plus t is equals to f of x. Then we say that f of x is said to be periodic function with period t, right? And this period and some trigonometric functions. If you take some trigonometric functions, sin x, cos x, secant x, cosecant x, they are the periodic function with period 2 pi. Tan x and cot x are the periodic function with period pi. Right, if f of x is a periodic function with period some t, then f of ax also periodic function with period t by a. Next, if you take the sum of the periodic functions, then to find the periodicity of that function, we take the LCM and some introduction to the periodic function and introduction to the Fourier series, and how we are going to find the Fourier coefficients we have discussed. Now, continuation of the last class. Now, continuation of the last class means finding the Fourier series of the functions. Today we are continuing the same finding the Fourier coefficients or for expanding the given function in the given interval as a Fourier series. Now, coming to problem, yeah, on Fourier series. Now, see this problem, obtain the Fourier series expansion or Fourier series for f of x is equals to x minus x square in the interval minus pi comma pi. And hence show that summation n is equals to 1 to infinity minus 1 over to the power of n minus 1 divided by n square is equals to pi square by 12. Or this deduction is same as pi square by 12 is equals to 1 by 1 square minus 1 by 2 square plus 1 by 3 square minus 1 by 4 square plus so on. Sometimes instead of hence show that reduce that. Using the above expansion, you have to reduce this relation or this expansion or this series. Okay, this is the alternating series. Now coming to solution. This given function f of x equals to x minus x square, which is defined in what minus pi comma pi. In previous we did two problems, they are interval in 0 comma 2 pi we taken, here is minus pi comma pi or 0 comma 2 pi or minus pi to 0 0 to pi, we are taking the same formulas for finding the Fourier coefficients a naught, a naught, a n and b. Now, the Fourier expansion of f of x is given by f of x is equals to a naught plus summation n is equals to 1 to infinity a cos n x plus b n sin n x. This is the Fourier expansion of any function, any function f of x. So this is the equation number 1. First calculation of the Fourier coefficients one by one I am trying to calculate here to find a naught. First, I am going to find the a naught. A naught is equals to you know that the formula a naught is equals to 1 by pi integral minus pi to pi f of x dx. That's 1 by pi integral minus pi to pi x into x minus x square dx. F of x is equals to what? X minus x square. X minus x square dx, which is 1 by pi into. Yes, you may apply one trick here. Here x is the limits are minus pi to pi. X is what? Odd function. So see here it is odd function between the limits minus pi to pi. Odd function integration is 0. X square is even function, minus pi to pi can be written as 0 to pi also, 2 into 0 to pi. Next we will discuss. Here as it is I am integrating with respect to x on both sides. So here integrating x dx is nothing but x square by 2. X square dx is nothing but x cube by 3. Where the limits from minus pi to pi, which is equals to 1 by pi integral or 1 by pi. I am substituting the pi square by 2 minus pi whole square is nothing but pi square. Pi square by 2 minus pi square by 2 it is 0. Next minus 1 by 3 into I am taking the upper limit pi cube minus of minus pi cube. Minus pi cube is nothing but minus pi whole cube it is minus pi cube. Before minus pi is there. Before minus is there. Pi cube plus pi cube. 2 pi cube divided by 3. 2 here it is 1 by pi into minus 2 pi cube divided by 3. 1 pi get cancelled, which is minus 2 pi square by 3. A naught is equals to minus 2 pi square by 3 is the first coefficient. Next I am going to find an. Yes, calculation of an or finding an. An is equals to 1 by pi integral minus pi to pi f of x cos nx dx. Right, 1 by pi minus pi to pi x minus x square cos nx dx. Yes, next we go for the Fourier series expansion of the even or odd functions. Yes, in the next class we will discuss. But here also I am applying without expanding, without finding the integration. It is not a simple function. It is not here. It is no problem for finding the a naught. Only one function is there integrating with respect to x without applying any integration by parts formula. A naught is equals to minus 2 pi by pi square by 3. Here not like that. So here x minus x square into cos nx dx, which is equals to 1 by pi into c. First I am trying to multiply x into cos nx, x into cos nx. You know that cos nx is always even function. What do you mean by even function? F of x is a function, f of minus x is equals to f of x for all x belongs to R. Such function is called even function. X square, x to the power of 4, cos x, secant x, they are the even function. Next, if f of minus x is equals to minus f of x, we say that that is an odd function. We will discuss, but we are applying, right, without finding the integration. Finding the integration is very important in the entire Fourier series. I told in the last class also. Right, x into cos x is what? Cos nx is odd function. So odd function integration minus pi to pi. If you find the integration and taking the limits also, you will get the 0 here. Here like this. Here it is x is odd function. If you find the integration of x dx and taking the limits from minus pi to pi, you will get 0, no? Same will get the 0 here. Right? Why it is an odd function? And my x square into cos nx. X square is the even function, cos nx is the even function. Product of the two even functions is also even function. So it is x square cos nx is the even function. So integral minus pi to pi can be written as 2 into integral 0 to pi x square into cos nx dx. This is a property of the integration here, definite integral. 2 into integral 0 to pi x square cos nx dx. Okay, if I am going to find this integral value, this integration value, right, then we'll get the an here. To find this one, I'm going to use this formula. This is last class I given Bernoulli's, Leibniz rule to find the integral uv dx. Here u is equals to x square, v is equals to cos nx. First, just see this right side. U is equal to x square, v is equal to cos nx is the second function. You take the derivatives of the first function like this, and you take the integrations one by one of the second function like this. X square derivative is 2x and 2x derivative is 2, 2 derivative is 0, 0 derivative is 0. That's why I am not writing here. Okay, next. Cos nx derivative is sin nx divided by n. Sin nx derivative is minus cos nx divided by n. Already one n is there, n square. Cos nx derivative is sin nx, before minus is there. By n square is there. You will get the n cube here. Is it clear? For first you should write what is the reason for writing this. Here if you here x square is there, x square into u into integral v dx minus integral of integral v dx into du by dx we are applying. Right, again you need to apply u into v. In order to overcome the situation, I am going to use this one, right? Yes, better to use this. First, whatever the function you are choosing as a first function, take that function as u, and the rest of the function that can be taken as v, and write it the derivatives of u one by one like this, and write it the successive integrations one by one. That successive integrations means v1 is the integration of v, v2 is the integration of, not integration of v, it is the integration of v1, v3 is the integration of v2. See, v1 is the integration of v1 v, v2 is the integration of v1, v3 is the integration of v2, like this. U triple dash is the integration of u double dash, u double dash is the integration of u dash, u dash is, sorry, u triple dash is the integration of u double dash, not integration, derivative. U triple dash is the derivative of u double dash, u double dash is the derivative of u dash, u dash is the derivative of u. Like that we have u dash, u double dash, u dash triple dash, so we have. So here it is, see, u is equals to x square here. U is equals to x square, v is equals to cos nx. I am going to use. Yes, the formula is what? uv1 alternatively positive and negative. uv1 minus u dash v2 plus u double dash v3 minus u triple dash v4. v4 will get v4, v5, v6. Every term is there in the integration. But here it is, we stop the at this stage. Why? Here u triple dash is 0, u fourth derivative is 0, u fifth derivative is 0. It's enough to take the 3 terms in the integration, right? Okay. U v1 x square into sin n x by n, right? Next, u dash v2. U dash is what? 2x into alternatively positive, negative, positive, negative will get x square into sin n x by n minus u dash. U dash is 2x. v2. V2 is nothing but minus cos n x divided by n square. Here minus is there. Next is plus 2 into u double dash into v3. 2 into V3 is minus sin nx divided by n cube. Clear? Is it clear for this step? Now, where the limits from where to where? 0 to pi. Now I am going to concentrating on the limit. If you write sin n pi, you know that sin n pi is equals to 0, right? Here it is, here sin n pi is 0, here pi square into sin n pi, here it is 2 into minus sin n pi, side terms completely 0 here, but that means we don't have any sine terms. Not only for substituting the upper limit, if you substitute the lower limit also, sin 0 is 0, right? Here sin 0 is 0, and in that case we don't expect the sine terms when we are substituting the lower limits and upper limit. Okay. Now only cos terms we have. Now coming to the cos term. Here minus into minus plus 2 into pi cos n pi divided by n square for upper limit. Now coming to the lower limit. Here it is minus into minus plus. Here plus is there. If you go for the lower limit, we will get a negative. Negative. Here it is 2x into 2 into 0. 0 into cos 0 divided by n square. So here it is. Finally 0 into anything it is 0. This term is completely 0. We have minus 2 into 2 minus 4, this pi get cancelled, minus 4 by n square into cos n pi, which is equals to minus 4 by n square into cos n pi is equals to minus 1 whole to the power of n. Sin n pi is 0, right? Cos n pi is minus 1 whole to the power of n. If n is even, we'll get 1. N is odd, we'll get minus 1. That's why we are writing cos n pi is equals to minus 1 whole to the power of n. Therefore, an is equals to minus 4 into minus 1 whole to the power of n divided by n square. This is an here. Next, calculation of bn. What is the formula for bn? Bn is equals to 1 by pi into integral minus pi to pi f of x into sin nx dx. But you know that given f of x is what? X minus x square, which is defined in the minus pi comma pi. Yeah, bn is equals to 1 by pi integral minus pi to pi f of x sin nx dx. 1 by pi integral minus pi to pi x minus x square into sin nx dx. Here also I am using the same concept of the even and odd function. Here x into sin nx. X is what? Odd function. See, f of x is equals to xi. If I am taking f of minus x is equals to minus f of x, that is minus x. So x into sin nx is odd function. So x sin nx is 0. Not 0. Listen, one thing here I want to tell. Right. If you go for the next class, I will get the clarity. That means I will give the definitions of the even odd function, product of the even odd, odd even, odd even even. X is the odd function, sin nx is the odd function. The product of the odd function is even function. Remember this. If I am taking f of x is equals to x, f of x is equals to x. Is it even function or odd function? It is clear that it is a odd function. F of x is equals to x cube. It is even function or odd function? Odd function. X into x cube is what? X to the power of 4. X to the power of 4 is all. It is always even function. That's why x into sin nx is even function. Minus pi to pi. So better to write 2 into integral 0 to pi x sin nx dx. This is a property from the definite integral here. That x square is the even function, sin nx is the odd function. Even into odd or odd into even is also odd, right? So x square into sin nx is the odd function. So integration of the odd function between the limits minus pi to pi, it is 0. Clear? Okay. Now here is you take out this 2 before the bracket, 2 by pi. Yes. Again, I am using the same this Leibniz rule for finding the integration by parts. Okay. Here first function is x and second function is sin nx. X into sin nx integration with respect to x is minus cos nx divided by n minus X derivative is what? 1 into cos nx derivative is sin nx, already minus there. Sin nx divided by n also there. So sin nx divided by n square we have, right? Minus sin nx divided by n square. What is the reason for getting minus here? Already here minus n is there. Cos integration is sin only, but here minus is there, same minus we have. Okay, where the limits from where to where? 0 to pi. You know that 0, if I am taking 0 or pi, sin n pi is 0, sin 0 is 0. That means we don't get this term, right? This term is completely vanished. Okay, only this term we have. Right, if you go for the upper limit, here plus x is there, x into minus, that is plus x plus into minus minus pi into cos n pi divided by n minus 0 into cos 0. Even cos 0 is equal to 1. Cos 0 is multiplied by 0, it is 0. Right? 0 by n, it is 0. Only one term we have, that is minus cos minus pi cos n pi divided by n. Yeah, this pi will cancel, which is equal to minus 2 by n into, here it is cos n pi is minus 1 over to the power of n. That means we have the Fourier constants. An is equals to minus 2 pi square by 3. Sorry, a naught is equals to minus 2 pi square by 3. An is equals to minus 4 minus 1 over to the power of minus 1 to the power n divided by n square. Bn is equals to minus 2 minus 1 to n by n. If you are substituting this in the sorry, this is not page, this is the next page here. If you are substituting this a naught an bn in equation number 1, we have the Fourier expansion of x minus x square in the interval minus pi comma pi is given by f of x is equals to minus pi square by 3, which is an, minus 4 into summation n is equals to 1 to infinity an cos nx. Here it is bn is equals to minus 2 into minus 1 over to the power of n by n, minus 2 into summation minus 1 over to the power of n by n sin nx. This is the Fourier series expansion. But problem not yet completed. You have to reduce, you have to find one deduction, one relation from the given expansion, from the Fourier series expansion. In this expansion, I am going to substitute x is equals to 0. How we can get this idea x is equals to 0? Based on pi square by 12. Here if I am writing here pi minus pi square by 3 is there. If you take out this term to the left side and you take out this 4 to the left side, you will get pi square by 12. But the RHS terms how we can get by taking the x is equals to 0. Put x is equals to 0 in the above equation. Now listen, minus pi square by 3 minus 4 into summation n is equals to 1 to infinity minus 1 over to the power of n divided by n square as it is cos nx, cos n into 0, that is cos 0. Cos 0 is 1 minus 2 into summation n is equals to 1 to infinity minus 1 over to the power of n divided by n. Sin 0 is 0. Sin 0 is 0. So we have only this term, right? That implies you take out this term to the left side. Or 4 into summation n is equals to 1 to infinity minus 1 over to the power of n divided by n square is equals to pi square by 3. So you take out this 4 to the right side. Summation n is equals to 1 to infinity minus 1 over to the power of n divided by n square is equals to uh, pi square by 12. Or pi square by 12 is equals to, if I are expanding, if n is equals to 1, that is minus 1. Minus 1 over to the power of 1 is minus 1 divided by 1 square. Next plus 2, 1 divided by 2 square. Minus 3 divided by n, that is 3 square. So on. We'll get the pi square by 12 expansion like this. You will get this one, right? Here it is minus pi square by 12 or plus pi square by 12. This is the expansion. Yeah. Expand f of x is equals to pi minus x whole square divided by 2. 0 less than x less than 2 pi. Same formulas for finding the a naught, a n, b n. So better to expand this. Pi minus x divided by 2 whole square is an even function or odd function. See here, that is if you are expanding, you will get a pi square plus x square plus 2 pi x divided by 2. right? It is power is there, better to expand this function and multiplying with sines cos nx sin nx for an and bn, you will get the a0 is equals to pi square by 6, an is equals to 1 by n square, bn is equals to 0, and substituting these values in the expansion you will get the answer. Discuss here. Is everything is calculation part, right? You are going to find the a naught, an, bn in the better way, right? That means integration is very important, finding the integration. If you are expert in the finding the a and b and a naught, the Fourier series is not a complex chapter. It's simple. Simply we can find the can expand any function as a Fourier series. Expand f of x is equals to x sin x in the interval 0 comma 2 pi as a Fourier series. Right, we have these constants and we are trying to solve this problem. We get a different case here. That is the reason we are taking this problem. This the Fourier series expansion of f of x in the given interval is f of x is equal to a naught by 2 plus summation n is equal to 1 to infinity an cos nx plus bn sin nx. Say this is equation number 1. Calculation of a naught. A naught is equal to 1 by pi integral 0 to 2 pi x sin nx dx. X is a here your limits are different. You don't think about the even or odd. Here minus pi to pi is there. You may think here it is here also you don't think about the even odd, right? The here the interval is different. 0 to 2 pi is there, right? Here it is 0 to 2 pi. It is interval of x. Okay, a naught is equals to this is the formula x sin x dx. Same using the integration by parts. X into sin x integration is minus cos x. X derivative is 1. Cos x integration is cos x integration is here cos x integration is sin x is there, right? It is sin x. So here plus sin x will get, I think, right? It is minus sin x. Before minus is there, so plus sin x we have. Integral 0 to 2 pi. Alright, here there is no effect for the answer here. What is the reason here? It is plus will get the plus here. Right, by sin 2 pi is 0, sin 0 is 0. Okay, change it. Here you will get a plus 2 pi into minus cos 2 pi. First upper limit. Next 0 into minus cos 0. Is it clear? But sin 2 pi is 0, sin 0 is 0. This term is completely vanished. Okay, 1 by pi of 2 pi into minus cos 2 pi. Cos n pi is equals to minus 1 whole to the power of n. So even number of n's cos n pi is 1. Odd number of n's cos n pi is minus 1. So we get cos 2 pi is what? 1. Here minus is there. 2 pi into minus 1. Is it clear? If I am writing x is equals to 2 pi, cos 2 pi is equals to 1 before minus is there. That's why minus 1. 1 by pi, 2 pi into minus 1. Pi get cancelled. It is a naught is equals to minus 2. Clear? A naught is equals to minus 2. Next, calculation of a. This is the formula. You know that 1 by pi integral 0 to 2 pi f of x cos nx dx. 1 by pi integral 0 to 2 pi x sin x cos nx dx. But here what is the given f of x? It is x sin x, sin nx. Here cos nx. Right, here you see this how many functions are there? X, sin, cos, cosine. 3 functions are there. So in this case, listen, right, it is not possible to apply integration by parts directly. To overcome this situation, I am going to multiplying with 2, dividing with 2. Multiplying with 2, dividing with 2. See. So x into 2 cos nx sin nx, 2 cos a sin b. 2 cos a sin b is what? Sin a plus b minus sin a minus b. Sin a plus b minus sin a minus b. That is compound angle formula. Right, 1 by 2 pi integral 0 to 2 pi x into sin a plus b, sin nx plus x. That is n plus 1 into x minus sin nx minus x, sin n minus 1 into x. Is it clear? Okay. So right, this is the first function, this is the second function. Clear now? This is the first function, this is integration by parts. See, 1 by 2 pi x into the integration of sin. It is minus cos n plus 1 into x divided by a. Cos ax integration is what? Sin ax integration is minus cos ax divided by a.
in place of s n plus 1 is there, so divided by n plus 1. Okay. Sine integration is minus cos, already minus is there, that minus into minus plus cos n minus 1 into x divided by n minus 1. Okay, minus x derivative is what? 1, right? By using this. V2, u double dash v3. Okay. X into integration of sin n plus 1 into x minus sin n minus 1 into x. Clear, this is the integration. Minus x derivative is 1. 1 into again the integration of this. It is cos integration is sine. Before minus is there, as it is minus sine of n plus 1 divided by n plus 1 by n plus 1. That is n plus 1 whole square. Okay. Here it is sine integration is cos. Right, sine integration is cos. Here is plus is same plus cos. Sine integration cos we have. Sine integration is minus cos, that minus into minus plus we have. Here cos integration is sine. Sine of n minus 1 into x divided by n minus 1 by n minus 1, that is n minus 1 whole square, where the limits from 0 to 2 pi. Right. Here one advantage we have. Whatever sign is there, if the limits are 0 to 2 pi or pi to minus pi to pi, that term is completely vanishes. Right? We don't concentrating on sine terms. So only we should concentrating on what? Cosine terms only. Right? Pi sine 2 pi into n plus 1 0. Sine 2 pi into n minus 1 is 0. This term is completely 0. Right. I go for the upper limit. 1 by 2 pi, 2 pi of minus cos. Here this denominator n minus 1 is there. Please remember, if I am taking n is equals to 1, this is not exist. This is infinity. Yes, this is infinity means this is not a expansion, right? So I am going to restrict the values of n here, that is n is not equals to 1. This is valid for n is not equals to 1. Here better to write this case, right? When you are integrating with respect to x once for sine, better to write n not equals to 1. So this is valid for n not equals to 1. That means where we are going to start the n is equals to 1 to infinity. But I don't take n is equals to 1 for this an. Just n not equals to 1 means n is equals to 2 will start. Right, we'll start from n is equals to 2. Okay, if you go for 2 pi into cos of minus n plus 1 into 2 pi divided by n plus 1 plus cos of n minus 1 into 2 pi divided by n minus 1. If you write the 0, minus cos into 0, cos 0 is minus 1 divided by n plus 1. Right? Next, plus listen, we'll do this. If you go for the upper limit, lower limit, that minus is there, no? Minus is there. Minus, yeah, sorry. Here, if you go for the lower limit, 0 into, right? Here x is there. This is depends upon x. 0 into cos, even cos 0 is equals to 1. Here cos 0 is equals to 1. Minus 1 divided by n plus 1. 1 divided by n plus 1. Multiplied by 0. So the term is completely 0 when we are substituting x is equals to 0. Right? Only this term we have. So cos 2n plus 1 and 2 pi is there. It is even. Even is multiplied by odd. So what we have? Even is multiplied by odd. Even into even. Even into odd. Even. So cos of n pi. This is 1. Here n minus 1 is even. So even is multiplied by, sorry, n minus 1 is odd. Odd is multiplied by even. It is even. So we get cos n minus 1 into 2 pi. 2 into n minus 1 into pi. That is even. So this is 1. This is also 1. Minus 1 divided by n plus 1 plus 1 divided by n minus 1. LCM is n plus 1 into n minus 1. So minus n plus 1 plus n minus 1. N get cancelled. 2 divided by n square minus 1. This is an for n not equals to 1. Okay. Same style. Equals to 1 by pi into integral 0 to 2 pi f of x into sin nx dx. So this is 1 by pi into integral 0 to 2 pi x sin x sin nx dx. Again, three functions are present here. So I'm going to use this formula, multiplying with 2 and dividing with 2. 2 sin nx cos sin x. 2 sin a sin b. Cos a minus b minus cos a plus b. Cos a minus b is what? Cos a cos b plus sin a sin b. Cos a plus b is what? Cos a cos b minus sin a sin b. Before minus is there. Minus cos a cos b plus sin a sin b. Plus cos a cos b minus cos a cos b get cancelled. Sin a sin b, sin a sin b, 2 sin a sin b. 2 sin a sin b can be written as cos a plus b nx plus x cos a minus b nx minus x minus cos nx plus x. This is 2 sin nx sin x can be written as cos n minus 1 into x cos n plus 1 into x. Right. Again, we go for the integration by parts formula x into u v dx. This is very important. This part, the calculation is very important. Okay. Here 1 by 2 pi integral x into cos integration is sin n minus 1 into x divided by n minus 1. Cos integration is sin minus sin, so, before minus is there, sin n plus 1 into x divided by n plus 1 minus 1. Right. First one u v1 minus u dash v2. U dash x derivative is 1. V2 is integration of this bracket, not integration of the given function. This is the integration. V2 is the integration of v1. Right. Sin integration is minus cos n minus 1 into x divided by n minus 1. Already one n minus 1 is there, n minus 1 whole square. Right. Here sin integration is minus, before minus is there, minus into minus plus cos n plus 1 into x divided by n plus 1 whole square, where the limits of x from 0 to 2 pi. You know that 2 pi is 0, the sign terms vanishes, right? We don't get these terms. Okay. Next, if you are multiplying with minus, this is what you are going to expect here. Minus into minus plus cos n minus 1 into x divided by n minus 1 whole square. Here it is minus cos n plus 1 into x divided by n plus 1 whole square, where the limits from 0 to 2 pi. Here also in the denominator n minus 1 whole square is there. If I am taking n is equals to 1, what happen? The term is infinity, infinity minus anything it is. Infinity, the term is not existing, so I am going to restate. This is valid for n not equals to 1. Right, n not equals to 1. Okay, I'm going to substitute the limits. Yes, upper limit 2 pi. Yes, cos of n minus 1 into 2 pi divided by n minus 1 whole square minus cos of n plus 1 into 2 pi divided by n plus 1 whole square. Right, upper limit is over. Next lower limit minus cos 0 divided by n minus 1 whole square is nothing but 1 divided by n minus whole square. That minus into minus plus 1 divided by n plus 1 whole square. Cos n minus 1 into 2 pi. Cos it is 1. Here this is also 1. 1 divided by n minus 1 whole square, 1 divided by n plus 1 whole square, minus 1 divided by n minus 1 whole square plus 1 divided by n plus 1 whole square. This term, this term, this term it get cancelled. We have bn is equals to 0. This is for n not equals to 1. Right. But when n is equals to 1, here an, we written an and bn for n not equals to 1. If I am taking n is equals to 1, I am trying to find a1 and b1. This is a different problem I have taken. When n is equals to 1, a1 is equals to, by using that formula, an is equals to what I am writing, 1 by pi integral 0 to 2 pi f of x into cos n x dx. Instead of n, what I am taking here, 1, n is equals to 1, this is the formula. 1 by pi integral 0 to 2 pi x sin x cos x. So again multiplying with 2, dividing with 2, 2 sin x cos x, it is nothing but sin 2x. You go for the integration by parts formula. Right, applying this, you will get a1 is equals to minus 1 by 2. In that general formula, a1 is not exist, n is equals to 1, that is not valid. But I separately find out a1, that is minus 1 by 2. In the same way, n1 is equals to 1, b1 this is sin x into sin x, sin square x, multiplying with 2, dividing with 2, 2 sin square x. 2 sin square x is replaced by 1 minus cos 2x, x into 1 minus cos 2x, integration by parts, x into x minus cos 2x, integration is sin 2x by 2, x derivative is 1, x integration is what, x square by 2, sin integration is cos, before minus is there, the sin integration is minus cos, before minus is there, that minus into minus plus, cos 2x by 2 square, that is 2 into 2, 4, 0 to 2 pi. Yes, here it is sin terms 0. Yes, if you are taking the limits 2 pi minus sin, it is, if after simplification by taking these limits, you will get b1 is equals to pi. Now I am going to substitute. I am trying to expand the f of x is equals to Listen, a naught by 2, a1 not included in the summation, right? That is different. A naught by 2 plus a1 cos x, summation n is equal to 2 to infinity a n cos n x plus b1 sin x, summation n is equal to 2 to infinity bn sin n x. Right, 1 by 2 into minus 2 minus 1 by 2 into cos x, why a1 is equal to minus 1 by 2 plus 2 into summation n is equal to 2 to infinity an is equal to 1 by n square minus 1 cos n x plus b1 is equals to pi sin nx, bn is equals to 0. Only b1 term we have, remaining terms are 0, right? This is the f of x expansion, right? This is about the f of x is equals to, what is the f of x here? This is expansion of the similar fashion. You are going to find problems here. You are going to divide the interval, right? A naught is equals to what you are going to write? Generally, A naught is equals to, what is the formula for A naught here? A naught formula. Yes, 1 by pi integral 0 to 2 pi you are writing. But here it is 0 to minus pi to pi. First it is minus pi to 0, one function is there, 0 to pi is there. 1 by pi into integral minus pi to pi f of x dx. So this can be written as 1 by pi into minus pi to 0 f of x dx plus 0 to pi f of x dx. Separate integration here for this one also. Sixth one, you take out this problem. And seventh one, this is the problem. F of x is equals to minus pi for the x value lies between minus pi to 0, and f of x is equals to x if the x value lies between 0 and pi. By using the expansion of f of x, which is defined in the interval, we are going to deduce this relation. Here it is, f of x is equals to, already we did one problem on x minus x square. This is for x plus x square in minus pi comma pi. F of x is equal to 1 plus 2x by pi in minus pi to 0. F of x is equal to minus 1 minus 2x by pi in 0 less than x less than pi. This is about the finding the Fourier series expansion in 0 to 2 pi or minus pi to 0, pi to pi, or if it is the function is splitting into intervals, right? So this is about, next class we go for finding the Fourier series expansion even or odd functions, right? Already we use the concept of the even or odd, right? If it is even, without calculating, we can write the coefficient as 0, right? That is we are going to discuss. Okay.